Hello YouTube, Sandre here. Today I'm going to take on a video that claims that radioactive dating is not trustworthy. And yep, it's a creationist making this claim. Let's begin.
Nearly every textbook and science magazine teaches that the Earth is billions of years old, and the primary dating method used for determining this is what is called radioisotope dating, or radiometric dating. Now this is a reliable method for measuring absolute ages of rocks and the age of the Earth, right? First off, many scientists now regard the age of the Earth to be between 4.55 and 4.6 billion years old. Okay, so if this method is reliable and accurate, why the 50 million year discrepancy? That seems like a lot.
We haven't been more than a few seconds into your video and already you're failing miserably. Sorry, but no. Radiometric dating is very reliable. It has an error range of about 0.1 to 1%. This means that the error of the age of the Earth is at most 0.1% to about 1% of 4.5 billion years. That's very accurate. Now, it's not just the age of the Earth that has been dated thanks to radiometric dating, but also the meteorites that we see in the sky. Now, since radiometric dating is so reliable, it also tells us how old not just our planet is, but the heavenly bodies in our solar system as a whole. Besides, it's not as if radiometric dating is the only thing we have to see how old the Earth is. We have other ways of dating the age of the Earth that we cross-check with each other too. It just so happens that it all coincides to about 4.5 billion years. Because like I explained before, the range of error of radiometric dating on such a timescale is somewhere between 0.1 to 1%. Now, it just so happens that if we assume 1% error range of that date, that is 45 million years, or almost 50 million. So what they do is that they round off that 45 million to 50 million just to be safe.
But let's get into some details here and see what's going on. Keep in mind that there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version of the process. Radiometric dating is the process of estimating the ages of rocks based on the decay of radioactive elements in them. Basically, there are certain kinds of atoms in nature that are unstable and spontaneously decay into other kinds of atoms. For instance, uranium will radioactively decay through a series of steps until it becomes the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is commonly used to date igneous rocks, rocks which formed when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escaped, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life. That is the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock. But is that all there is to it? Here's where it gets tricky. It's true we can measure a decay rate using observational science, but there's another kind of science that is required to accurately calculate dates for rocks, and that is what we call historical science.
Why is it that fundamentalist Christians like yourself, who so vividly promote the teachings of the Ten Commandments and see them as good morals, are usually the ones who most often break those 10 Commandments? Especially the part about bearing false witness. You see, you did a pretty good job until you came to the historical science part. Everything else was relatively accurate. There are some things I could nitpick, but I'm not going to. But when it comes to historical science, now you're just making shit up. There is no such classification of science whatsoever. I should know. I am actually a scientist in training.
Historical science deals with the things in the past, and therefore it cannot be repeated and tested.
I'm sorry, what? What? What the hell are you even talking about here? Of course we can recreate the past. It is true that we live in the present, yes, but that doesn't mean that we can't make significantly accurate claims of the past. After all, the present wouldn't exist without the past preceding it, right? For instance, you are the age you are because you used to be younger And if we go further back, we can see that you were born at some point. Even further back, we come to the moment of your inception. In this case, yours must have been a huge disappointment for humanity. All God's creatures are magnificent, my ass. Anyway, insults pending. My point is this. You can definitely make certain claims of the past based on the present. For instance, if you take a cup of coffee and put your hand to the side, you can sense that it is lukewarm. This tells you that it used to be hot. How do we know this? Because the process of solvating the substances that you find in a cup of coffee from the coffee grain requires water to be hot, at least far warmer than lukewarm. If we were to go by your standard, we would have to release every single prisoner in prison because, hey, we don't know the past. This guy supposedly murdered someone, but hey, he's probably innocent because, you know, guys, we only live in the present. We can't make any determinate statements of the past based on present states.
Dating methods require both types of science, because in order to get accurate rock dates, one would have to accurately know both the decay rate and the initial conditions of the rock sample, right?
Here you go again with these fake labels. Observational science, historical science. No, stop. And we do know the decay rate, which we can observe, as well as the initial state of the rocks. After all, the variable of any type of decay formula requires that we know the initial state of something. In other words, the math simply wouldn't work unless we knew the initial state of whatever it is that we measure the decay of.
Since radioisotope dating uses both types of science, we can't directly measure the ages of rocks. There are assumptions involved.
That's funny. So saying that God did it isn't making a huge-ass assumption?
For instance, how do we know what the initial conditions were in the rock sample? How do we know the amounts of parent or daughter elements now in that sample haven't been altered by other processes in the past?
Now let's talk about the rocks that you bring up. You see, at the very early formation of the Earth, most things on Earth was actually kind of liquid. Now, as long as the rock is liquid or lava, many of the elements that we call daughter elements of radioactive decay could indeed interact with this molten rock and actually be part of it. So a daughter element of uranium, for instance, could indeed be in this rock at this point. Now, if this daughter element stayed in the rock for the continuous future, this would indeed be a problem for us, but that's not the case. When the molten rock starts to cool down and form a solid shape, most of the daughter elements escape. And since the rock is now solid, it's very hard for these daughter elements to once again become a part of the rock. This leaves only the parent atoms that are gonna decay, such as uranium, for instance. It is from the point of the rock being hardened that we then can say that any daughter element that's part of the rock is due to that radioactive decay. Hence, we do have a way to measure the age of that rock by looking at how much of the original parent atom has decayed, such as uranium. Now, of course, the exact way that we do the radiometric dating depends very much on what it is you want to date. So my example isn't 100%, mind you. It does differ from example to example.
How does someone know the decay rate has remained constant since the rock formed?
Because, genius, a universal constant wouldn't be a constant if it wasn't constant. Now, since we can derive these constants mathematically from these formulas, it tells us that, yeah, it's pretty much a constant. Pretty much all of the math that is used in most sciences is based on these constants of the universe. No matter how much we do an experiment to see how fast a photon is, it's always the speed of light, or c.
The answer is they don't.
You lying son of a bitch.
Here and talk about a typical hourglass. Let's say you walk into a room and you see an hourglass with sand at the top and sand at the bottom, and some sand sprinkling from the top chamber to the bottom. Well, observational science would allow us to see and measure the sand, and then calculate how long the hourglass has been running, right? We could make our sand measurements and then calculate when the hourglass was turned over, right? Well, those calculations could be wrong, because we may have failed to consider some major assumptions, like, was there any sand at the bottom when the hourglass was turned over? Has any sand been added or taken out of the hourglass? Has the sand always been falling at a constant rate? Since we did not observe the initial conditions when the hourglass started, and we haven't been watching the sand all the time since then, we must make assumptions. All three of those assumptions can affect our time calculations. Now, of course, there's more to understanding all of this, but enough said.
Oh, for fuck's sake. This is why, in analysis, we are so anal about getting it right. We take all kinds of safety precautions just to make sure that we don't introduce a bias, such as through contamination, for instance. You talk about decay, and if we were to assume that what you're saying is true, that maybe decay in the past was faster, just to make it appear that the Earth is somewhere around 4.5 billion years old, and only now slowed down for whatever reason, then the Earth as you know it simply wouldn't exist. Have you heard of something called the mantle of the Earth? It's below the Earth's crust. Basically, it's molten rock in a layer of the Earth. Now, this layer is very hot, and one of the reasons that it is hot is because of radioactive decay. If the decay rate, even just a few thousand years ago, was way faster than it is today for some reason, we can easily calculate using some math and knowing thermodynamics that even today, the Earth would still look entirely like the mantle below the Earth's crust. There wouldn't be a crust of the Earth. The Earth would just look like a big glowing red ball, because wherever you were on the Earth, it would be nothing but lava. Unless you want to argue that the laws of thermodynamics and not just radioactive decay was different a couple of thousands of years ago, then what you're proposing is not consistent at all with anything we know. Even by your own internal logic of the arguments you give, you would not just have to argue that radioactive dating was different a couple of thousands of years ago, but also the very basic laws of thermodynamics. So in order to explain your leap of preposterous assumptions, you would have to make yet another preposterous assumption. And what I have to say about that is, go fuck yourself. No. Just no. That's not how science works. And what you're saying just isn't in line with everything we know about the scientific data. Anyway, thank you all for watching. Make sure that you're not just subscribed, but also click the bell. I've had a huge problem as of late with people not being notified in their subscription feed. And if you click that bell, there's a higher chance that you're actually going to be aware when I upload a video. Also make sure you follow me on Twitter, because I update there whenever I upload a video. Anyway, that's it. Thank you for watching. Bye!